This one is squared.
Yes.
Here the square is equal to y over y prime.
Yes.
Square is equal to this. So I will just write y over y prime. Now I can write that in order to simplify this thing, if I just multiply all of this, if I multiply all of this with y prime, then what it will be? If I solve this for y prime, so I will just multiply this with this and I can write that y prime and a square plus y square means I multiply this with y, then it will be y prime a square plus y square and minus y times a square plus y prime square is equal to 0. Means multiplying with y. Okay? And now, if you look here, this is y prime. So, with this one, a square y prime, y square y prime. If I come here, y a square and then y prime square times y. So, my equation is becoming quadratic in both y and y prime. But what is my requirement? My requirement is like this. I found the induced charge in terms of the source charge. So my desire or my requirement is to find the distance of the induced charge in terms of the source charge. So y prime is my variable. And now I will convert my equation into y prime. Means I will then divide by that one y. So this implies that y prime squared minus a square plus y square by y and y prime plus a square is equal to 0. How I got this? Look here. Y prime square is here, so it will be a square y multiplied by y prime square y. So I will divide by y, all the equation. If I divide by y, then it will be y prime square. This whole will be divided by y. So it is here, a square plus y square whole divided by y into this y prime. And then come here. This one was a square y, so it was divided by y, so it will become a square only. And now it's a quadratic equation, and the quadratic equation is, you can just make this thing into components as well. I can write this, that this can also be written as y prime minus a squared over y and y prime minus y is equal to 0. Can I write like this? Look here. What will be the multiplication? Means I'm converting this thing into a square minus b square. So I just combine these two. If I do this multiplication, I will directly get this one. Look here. Y with y prime will become y prime square. So it is there. Then it will be y with y prime with y. Then this will be a square by y with y prime. And then plus y will cancel and only a square will remain. So this will be a square. You can direct multiply and then you can check that yes, this is right. Okay. Now what this one is giving us? This one is giving that y prime is equal to y. This result is not attracting me much. Why? Because this was the known fact to me that this distance will be the same as this one and the charges will be the same. Because you know, when y prime will be equal to y, then here this will become 1 and q will be equal to minus q. Q prime will be equal to minus q. That was our simplest case. So this result is not, you can say, attracting much. What about this one? This one is telling you that y prime is equal to a square over y. Now this result is interesting in the sense that I found y prime value in terms of y. This was my requirement.
So this is possible if the conducting sphere has a thin surface.
Yes.
So in that situation, the
Yes, thin surface, yes. Mean negligible thickness.
negligible thickness.
Right? It will be just like a boundary. Boundary is surface.
Yes.
It's just a surface. Surface is defined as plane. Plane means having negligible thickness. You cannot count on thickness. So y prime is equal to a square. Is this dimensionally right?
Yes, sir.
No.
Yes, that's right.
This is length squared divided by length. So dimensionally, this one is right. Means it seems that this one is inverse proportional, but here is length squared. So don't ignore that. So you got, yes?
So I didn't get this. Why prime equals y is not significant?
Yes. Okay. So let me write, then you will get convinced. This is trivial. Why trivial? Because it told me y prime will be equal to y. When y prime is equal to y, then q prime is equal to minus q. And the very complex geometry has gone to the very simplest geometry. This I know. Mean I want something new here from this geometry. So the other solution is a fancier. Is a fancy solution. That y prime is a square over y. Okay, so we got two results and now we will have to merge them as well. And to merge them, our q prime was equal to plus minus q y prime over y. So our q prime, this implies that our q prime is equal to minus q a over y, and our y prime is equal to a square over y. These are actually our two results. Now I hope you understand why this one is equal to this.
So the first is also block for the
Yes.
q prime equals to minus q ay. After you consider q into under root y prime upon y.
Yes.
A square y
So,
square.
what you will put the y prime value there. So y prime will be equal to a square over y. Y prime will be equal to a square over y. A square over y square. So out of the square root it will become minus q a over y.
Yes.
Clear? Yes. Okay. So this was the merger of the two within the sphere. Now I am having the freedom that I can adjust a and y because a is in my control, or if not in control, then y is in your control because your source charge is with you. So you can move it back and forth in order to adjust the potential 0 there. Clear? Similarly, this one as well. Y prime means it is already in that solution. So you can adjust your boundary condition there. You can adjust the potential on the boundary. Now we know as Q moves closer to the surface, then the image moves closer to the surface as well. Like you are reducing y. You are reducing y. Then y prime is growing. Y prime is this distance. So the image charge is also coming to the surface. Actually, for a conductor, there is no concept of the charge at the center. It will always go to the surface. But when you consider both the things on the surface, then you will not be able to do any mathematics. So that's why you consider it inside, and then you do proper mathematics, and then on the limiting conditions, you derive some results. Okay. Now, what's about the next thing that we would like to find the attractive force. That what kind of force of attraction will be there. So the attractive force, to calculate the attractive force. Now the attractive force is K, F is equal to K, Q prime. And what's the distance between them? Y minus y prime, and this will be squared, right? Y minus y prime will be squared. So better I remove the absolutes because it's a force, so I will have to write y minus y prime squared. Because the distance between these two, the total distance is y, then you will have to subtract this distance from it. Because y is from the center, y prime is also from the center. So the net distance between q and q prime will be y minus y prime. So it will be this distance only. This is the force. Now put the values of q prime and y prime, and we will have this is equal to k and minus q a over y divided by y minus a squared over y whole squared. Means for q prime I put q times a over y, and for y prime I put a squared over y, and then I do some simplification, and the simplification is like this, that I take k and then minus q squared over a squared divided by y over a whole cube 1 minus a squared over y squared whole squared. Can I do like this? Look here. K is here, so K is here. K here. Minus Q squared and then A over Y. Right? Minus Q squared A over Y. So I left minus Q, right? And then A over Y is here. So keep this in mind that from here we will do this one. Now what I do from here, I take this A over Y here, for example, if I move here. So A will come here and Y will come here, right? And I take one Y common from here. So one y was this one and one y from here, so it will become y cube. Clear? It will become y cube. Then it will become 1, and this one a square over y square, because you take y common. This means you divide by y this one and this one. So this will become 1 and this will become y square. So a square over y square whole square. You are having y cube here. A over y cube. And we are having a square here. This was only a. Okay, right. Only a was there. So now if I write this one is y over a cube, so one square I did extra. And that square will be divided here. Clear? It means when I move this one up, it will be multiplied as a cube. A square will cancel with 2 of it, so only one a will remain there. So I will give this equation there. I mean, there is a reason why I am writing this in this form, because when I will put limiting conditions on this one, then it will be easier to calculate. You got it?
Yes.
Anyone having doubt in this calculation? You just reshuffle it. This is a cube. When it will go, it will become numerator here. And numerator will simplify with this one. So it will become minus q times a. And then this y you bring inside it, it will become again this one. Because one y was there. Clear?
Yes.
So if this is clear to you, then now you can put a very nice limiting condition. Okay. What will happen to this one? When y will be very, very greater than a. What is y? Y is your source distance. If your source will be much, much far away compared to the radius of the sphere, right? Like when you are going far away from the source, from the sphere, then the sphere will be also becoming like a point charge for you. You are going away from it. So it can behave like 2 point charges. And now look here, that when y will be very, very greater than a, then f will be approximately 1 over y cube. Let's see. When y is very, very greater than a, then what this one will become? This is the opposite of it, means y is huge. This one is growing. So this a square over y is going to 0. This will become 1. And your expression will become 1 over y cube. Because y is your variable, a is fixed. Right? A is fixed. This is the radius of the sphere. So your force becomes 1 over r cube. And when you put y approximately r greater r equal to a, right? Then your f will become approximately 1 over y squared. How? Look here. Do multiply means this one. A over y, bring it here. So what it will become? It will become y over a. Now from our, if you put even the limiting condition here as well, no problem with this one. Now your y is approximately equal to the a or slightly greater than this one. So it will be what value? When a will be exactly equal to y, then it will be 0, right? So 1 minus 1 0. So for, but you will have to calculate this one as this with it. If y is slightly greater than a, then this value will become slightly less than 1, right? Okay. Look here, then this one. Y means you do a little bit more mathematics here, then it will become